Welcome back to the channel. So today we're working on the Mark II again. Today we're doing a mod which this engine originally came with, but is even more needed now with the engine being a lower compression ratio. So it struggles to idle a lot. Even when it's hot, it struggles to maintain an idle. So if you can see right here, the screw, the idle adjustment screw, is all the way out and it still struggles to idle. It has these vacuum ports. This is the brake, underneath is the boost and the map, and over here we had this port that I just blocked off. So I put a pipe onto it in order to try and run a idle air control valve. So as you can see, I just plumbed up an idle air control valve. This is a VW idle air control valve with Bosch, made by Bosch, but it was previously on my 2.1 liter microbus, and it seems to be the same idle air control valve as the 1.8Ts. Let me just quickly show you guys which valves are supported by Speeduino. So the easiest are just the valves you can wire straight up to the board. The boost controller and the idle air control circuits internally on the board are the same. Both use transistors and they ground out the pin, and that operates the valves. Obviously the idle air control valve has more volume flow, so it can increase the volume flow of air to the engine and increases the RPM, whilst boost controllers have less volume flow, more precise. Anyway, so these are the options. You have the on-off type. I have seen some of these on VWs, and you can see they have small what do you call this, barb fittings, almost at nipples. They have small barb fittings, and these probably work as well. And you can see they're small because you can only allow that much air to flow through them, otherwise your car revs really high when it gets warm or when it's warming up. The second type is PWM. You can use PWM in open loop or closed loop, but the closed loop does use open loop as well, because you have to set up the table parameters initially using open loop. Open loop just means it doesn't use input to change the idle, and closed loop means the ECU uses input from the engine like RPM signal and temperature to set the idle. The third type is the stepper motors. I did skip over something. I just want to show you this. So you can use both 2-wire and 3-wire idle air controllers. 2-wire, and my valve looks exactly like this one in the picture. It's a common valve used. It's a Bosch valve. I don't know the port number, but I don't know, it comes on quite a few VWs. The third type, probably fourth, if you want to separate the 2-wire and the 3-wire VWM idle air control valve. So the fourth type would be stepper motors. Stepper motors use more coils internally and count the number of steps, and you do need a driver, so that is a little bit complicating. You have to wire all that in on the board. You can just plug it, as you see in this picture. You can just solder it onto your board if you want to do that, but I'm just using a PWM 2-wire idle air control valve. So the idea for this was just use it as an on-off valve, but after figuring it out, it seems I can actually use it as a PWM valve. Now to set it up in the software. So my ECU is not currently connected, as you can see, not connected, but I can still show you how it's done. So you could use idle advanced settings. This is just a play on the timing, so it sees the difference in RPMs and it advances or retards timing. You could use this as a substitute for your idle air control valve, but I'm not using it since it didn't work for me. After trying to use it, if I advance the timing, the combustion just becomes unstable and the car doesn't idle. So we're not using that. So to set up the PWM idle control, go over to idle, as I showed you right there, idle control, and you could use on off. You have a small enough valve just for initial startups and letting it warm up, and letting the ECU switch it off when the car is warmed up. So I'm using open loop PWM, and you have to do this if you're setting up closed loop as well. This is the crank taper run, so it's how it tapers off. Crank to run taper. Soft time transition from cranking to running PWM. Okay, so it has two duty cycle maps. There are the cranking duty cycle and the running duty cycle, so it transitions between the two using that time as a buffer. Now to setting up the valve, you need to know the frequency. I just say start as low as possible and work it up. If your frequency is too low, your valve will be making a humming noise. So you just turn up your frequency and see where the humming noise goes away. And that's about as good as you'll ever get it. You could already search up the frequencies. You could run the valve before the car starts. So that's what I'm doing, so the car starts a little bit easier. Or you could run it afterwards. And this means if you have 100% on normal, it means 100% duty cycle, the valve is all the way open. If you have it on the reverse, it means 100% duty cycle, the valve is all the way closed. So I'm using it on normal. I have tested out the frequency and it was about 250 on this valve. Frequency, you have to set up the frequency before you set up the duty cycle, since the frequency heavily affects the duty cycle. And now you're just going to do is burn that and then close it. It probably give you a prompt to restart your ECUs, and then just unplug it from your laptop and plug it back in, switch off the car, switch it back. You don't even have to switch on the car to do any of these settings. Next thing is to set up your duty cycle. So over here you would just change the duty cycle according to the temperatures. So I would say about this range in temperature below 50, you give it quite a little bit more duty cycle. Over here I would say give all of these quite a bit of a duty cycle, about 50 for mine. And because my car is boosted, I'm going to decrease all of these around 70 plus to 0, so that there's no boost leaks from the idle air control valve. The other tuning you have to do is the cranking duty cycle. For this you just have to set up the duty cycles according to the temperature every time your car starts. So if you want your car to start easy, or if it starts difficult, you just give it more duty cycle to open up, so it would rev up when you start it and then come back down. Yeah, this should make your car a lot easier to start. It should make my car a lot easier to start. Alright, so it's on none right now, so no idle air control valve. So I'm going to start it up and you guys can see what happens. I'm going to give it some throttle input because it struggles to start. See, very bouncy idle. So I'm just going to switch it on so you guys can hear the difference it makes. As you can see, 2000 RPM just from that valve being open. Okay, so it just went off because it does have fast idle set to 60 degrees Celsius. The engine hit 60 degrees Celsius and the idle air control valve went off. So that's the only setting you can do on the on-offs. Now I'm going to switch it over to PWM right over there, open loop, and see what happens now. Idle's up. So with PWM you have to set up the duty cycle. Right now it's on 75, so I'm just going to, this is not how it came, I have been tampering with this graph, so I'm just going to turn it all down a bit. 40, 50, 40, oh it's a bit higher, 50, 35. I'm just going to set it up around this temperature so I can show you. I have a little demonstration right there. So right now we have 700-ish RPM. It's in between these two blocks. I'm just going to increase both of these blocks by 10. So I'm going to make that 50, make that 60. You see very little effect on the RPM. 60 and I hear a humming coming from the valve. Let me just see if I can get that on camera. So that humming is an indication of wrong frequency. So we have to switch out that frequency, and that's basic. The frequency is the basis of all the tuning. It's obvious there's a lot of humming, so I'm just gonna increase the frequency. So I have been playing around with this. Let's see what 200 does, and it does say this requires a power cycle, so we're going to have to switch this off. The car is already off, so I just have to burn this unplug the laptop, plug it back in, connect it, and as you can see, idle frequency is at 200. Let's see if it still has the hum when the car's idling. Keeping an eye on the RPM. Yep, I still hear the humming. It's very apparent the higher the duty cycle is. I've changed it to 70, it should sound a lot worse. Oh, it actually went away. Seems like around about 65, it doesn't like that frequency. Yep, there it is. So I'm going to increase the frequency a little more, maybe to 20, and see if that changes it. Alright, so there we go, we have our table set up. This is our running table and our cranking table. Our cranking table is just default and it works pretty good on default, so I'm just gonna leave it as is. And that's about it for this video. The car runs really well, and next week we're going to switch the car over to sequential injection. If you want to see that on a 180, then go ahead and watch the next video. Peace!